Alright, so we took a quiz the other day where we looked at a couple graphs. They weren't these exact ones, I'm just kind of making some up. And I had you list the amplitude and the period and the range and then describe the translations. And a lot of people had trouble with this, so I wanted to make a video just talking about a couple examples here. I'll add a couple more when I get some board space. So I'm looking at this first graph. The first thing we're going to talk about is the amplitude. In other words, what's the max minus the min times the half? So amplitude for sine, well, we know that normally sine goes between 1 and negative 1. But notice the difference is here on our graph we have this 2 out front. Think about what that 2 is going to do to your graph. It's going to be a vertical stretch by 2. So instead of being between 1 and negative 1, our graph's going to stretch vertically and be between negative 2 and 2. But wait, there's more. Think about what the 1 is going to do to your graph. Well, it's going to shift everything up 1 unit. So instead of being between negative 2 and 2, it'll be between 3 and negative 1. So altogether your maximum value will be 3 and your min will be negative 1. That's a total of 4 units there. Half of 4 is, of course, 2. Turns out we could have just looked at this number in front, and that'll always tell you what your amplitude is. So yeah, you're really just looking to see what's the vertical stretch, because that's going to tell you exactly what you want your amplitude to be. Next thing we want to look at is period. We talked about before how period for sine was 2 pi units. Turns out that if you divide, well, look, let's slow down. Think about, we saw here the 2, we said that was a vertical stretch. It takes all your y values and doubles them. It's going to stretch your graph out vertically like this. We've also talked about things right here in front of the x, what they do. It's actually either a horizontal compression, so it makes your graph smaller horizontally, or it's a horizontal stretch. It's going to stretch it out horizontally. It turns out if it's bigger than 1, if the absolute value, I should say, of the number, if the number itself, regardless if it's positive or negative, if it's bigger than 1, that's a horizontal compression. It actually makes your graph smaller. And to find the period, you're really just going to take 2 pi and divide it by whatever that number is. So in this case, if we've got a 3, it'll be 2 pi over 3. So instead of the period being 2 pi units long, it's 2/3 pi, which is much, much smaller because our graph was compressed horizontally. The other thing we're going to talk about was range. So I already made a little sketch here that helps us with that. We can see that it would be between negative 1 and 3. We'd have something like this. It'd look something like that. That's a rough sketch. So there's your little sine graph. You can see it goes between negative 1 and 3. And then the last thing we're going to talk about is the translations, which we've already kind of done as we went through these. So we know that 2 out in front, we said, was a vertical stretch by a factor of 2. And we said that that 3 was a horizontal compression by a factor of 1/3. Remember, it's making your graph smaller, so you wouldn't be compressing it by 3. Multiplying things by 3 makes them bigger. And then the last thing here is this plus 1. That's going to take your whole graph and shift it up 1 unit. So that's what I was kind of looking for when you were doing the sine problem. This is tell me the amplitude, the period, the range, and then tell me what the translations were on the graph. You don't actually have to sketch a graph, and it may help you if you kind of draw a little picture to get the other values here. But yeah, so be sure you're practicing your homework and actually trying these problems. Otherwise it might be really complicated. They should be a piece of cake given all the times we've studied transformations. It's just applying these 2 new words here and then thinking about the graph. So then tangent down here, this graph's a little different. This time we have a horizontal compression and a horizontal shift. It turns out that what happens first is the compression. So it's really helpful usually if we'll take that number in front of the x and we'll factor it out. It helps us visualize what we're actually shifting around. Let me go to list the translations. So tangent, thinking about the amplitude. Well, we looked at the graph of tangent just a second ago, or in the last video. It looks something like this, with a whole bunch of asymptotes around it. And so notice that it has arrows on both ends. It's going off forever and ever. It means there's not going to be a max or a min, so you can't subtract max minus min and take half of it. Turns out tangent doesn't have an amplitude. Not available. It does have a period though. We also saw that the period is just pi units. It only takes pi units for the tangent graph to start repeating itself. The range for tangent, I guess I shouldn't have erased that right then, but if you need to go back, you can scroll your video backwards. You see that the range would be from negative infinity to positive infinity. Write that as such. And then the last thing we have to do is list the translations. Well, the first thing we come across looking at this is the 2 here. We've already said that's a horizontal compression. I'm going to abbreviate by a half. This number here is a shift to the left, pi over 2 units, and the shift down 1 unit. So that'd be all for that one. So I've still got a little bit of time left. Let's do a couple more examples. And actually, I'm going to write them down. And I'd like for you to pause the video and see if you can do them by yourself first. Again, I want you to list out the amplitude, the period, the range, and then the translations. Tell me what you know about the graph. Alright, and then I'll show you the answers. So once you see the problems, pause the video, see if you can figure them out by yourself. I'll make these relatively easy. And I don't know, let's do a cosine graph. Negative cosine of negative 2x plus pi. And I guess we'll stop that one there. So see if you can find these things over here for these two functions. So, time out. Alright, so hopefully you paused the video and actually tried these. I'm going to go ahead and work through them. So the amplitude, this is a cosecant graph. As we saw in the last video, cosecant looks something like this. It's got a whole bunch of asymptotes. Sorry, I had to pause there for a second, think about what sine actually looks like. So cosecant would look something like this. You'll notice there are no numbers on my graph. I'm just drawing the general shape. Roughly something like this. Or this right here is my y-axis. This is my x-axis. So you'll notice that just like the tangent graph, we don't have a max or min, which makes it impossible to determine the amplitude. So we'd say we don't have an amplitude. So the amplitude does not exist, or not available, or however you want to write it. Period, on the other hand, does exist. It's the exact same as sine, which we said was 2 pi divided by whatever number's in front of x. In this case it's 1. So 2 pi over 1 is just 2 pi. The range, we have to think about some translations here for this one. So normally if we want to sketch cosecant, we look at sine first. So if I change that cosecant to a sine, and think about the translations I've got. Normally sine goes between negative 1 and positive 1. But I've stretched everything by 2. So that's 2 and negative 2. And I've also moved everything up 1 unit. So that's 3. And if I add 1 to negative 2, it's negative 1. So the range for sine would be between negative 1 and 3. But I'm not graphing sine. I'm graphing cosecant. So cosecant is actually going to go the other direction. It's not inside these values, it's outside them. It's the U-shaped thing. So the range for this graph would be between negative infinity and negative 1. So from negative infinity up to negative 1. And then from 3 up to positive infinity. So we write that like this. So I'll erase my little graph here. Give myself a little more room. So the range looks like this here. And then we can quickly list out the translations. The negative out front is actually a reflection. And it's a reflection over the x-axis. The 2, of course, we said was a vertical stretch by 2. And the plus 1 takes your whole graph and moves it up 1 unit. So there's your 3 translations. Alright, so hopefully you did good with that one. If you want to pause it and try the next one if you didn't try this one already, to see what you can do. Remember that if you are trying this, that this number in front needs to be factored out before you'll get the horizontal shift correct. So you've got to factor out a negative 2. Alright, so let's go ahead and look at this one. So I'm going to go ahead and factor out that negative 2 first. I'll get this here. Alright, so the amplitude, this is a cosine graph, so I do have an amplitude. It's determined by whatever the number in front is. So I'll have a 1 out front, so my amplitude isn't changed from what it normally is, it's still 1. So the period for cosine, we talked about before, it's 2 pi divided by whatever number is in front of the x. So we've got a negative 2 here. The negative part doesn't really matter because period measures a distance, and distance can't be negative. So we're just worried about the 2. So 2 pi divided by 2, well, that would just be 1 pi. So the period of this graph would just be pi units long. Alright. The range, well, we haven't done anything to this graph vertically. We've got horizontal compression and we've got a horizontal shift, but we haven't stretched it vertically or moved it up and down. So the range hasn't changed from what it normally is. It normally goes between negative 1 and positive 1, and it's still going to do just that. But the translations, if we translate this graph, we're looking at the negatives. We've got 2 of them. So this one would be a reflection over the x-axis. This one would be a reflection over the y-axis. We don't have to write both of those reflections. We can actually simplify it down to just one. It's a reflection across the origin. Okay. So that's the 2 negatives that we see. And we already mentioned that the 2 was a horizontal compression by a half. And then we're shifting our whole graph over to the right, pi over 2 units. So be really careful that you actually do factor out whatever that number is in front. In this case we had a negative 2. Be sure you factor that out. Otherwise it'll mess up your shift here. You're not actually shifting to the left pi at all. You're shifting to the right pi over 2. So it's really important to catch. Alright, so you still got a couple problems that you can look up on the class website if you want to try some more of these for examples, or just make something up. Just throw together a trig function and throw in some numbers in front and some here, and see if you can figure out the translations yourself. If you want to check yourself to see if you got it right, just come see me in the morning and I'll help you. So that was a brief introduction to listing amplitude, period, range, and translations. Hope it helps. You will see this stuff on Thursday on the test. So there you go.